Hello everyone and welcome to Handmade Hero, show where we code a complete game live on stream. I forgot to log into our GitHub again, but you know what? We don't really need it right now anyway. So I'm gonna reset my clock here because it's 12:30 and I was supposed to start at 12:15, and I want to actually have all the time today because I'm not really sure what I'm gonna do, but I suspect it's gonna be kind of digging into some rendering stuff, and I want all the time I can get. So this was going to be day 546. Let's go ahead and end this and then pretend we're starting a new session at 12:30. There we go. So what we did yesterday is we took advantage of the entity system changes that we made the other day to create some ground cover, right? In a way that doesn't really affect the rest of our system negatively, which is nice. But there's a lot of things that we need to do. I mean, all we did was splat it down there. And so we're more or less accomplished what we wanted to accomplish, but it helped bring up a bunch of the stuff that we now need to do to finish polishing up our system. So just looking at the ground cover right now, several things I want to mention. First of all, it's not lit. And so lighting our sprites is a big thing that's been on our to-do list for a while. You can see that this really pushes that issue because you get a complete mismatch. The ground cover looks terrible against the background because the underlying cube should be roughly the same color to sort of prevent you from seeing show-through areas of the little grass that's sort of popping up, right? But since we don't light it, it's never going to, because you never would know what it should be set to in terms of color. And then similarly, we also can see now, and this is probably something that maybe only I can see because I do suspect that the video compression that happens when you're streaming or watching something on YouTube will prevent you from actually really seeing this. But if you look at what's happening here, when we zoom in, you can see these are nice and detailed and smooth. As we zoom out, we're not using MIP mapping. And so what will happen is we get lots of little crispy sparkles. And that's because, again, MIP mapping, when we actually do texture sampling in a 3D graphics card, the texture sampling is going to do a bilinear filter for us by default in the way we have it set up. And what a bilinear filter is going to do is going to sample two neighboring texels in the texture for both rows, right? So the bilinear is two neighboring texels, both rows. It's going to lerp those together, and it's going to lerp the result together to get essentially like a box filter, right? So essentially taking four texels and lerping, doing the bilinear between them to figure out what the color should be. What that means is that we will get reasonable filtering so long as we don't shrink our texture down by more than a factor of 2. But once we shrink it down by more than a factor of 2, we're effectively asking the graphics card to use 4 texels to approximate an area that's much larger than 4 texels. Because once we shrink it down by, say, a power of 4, there's actually 16 texels, right? That should be represented in 1 pixel's worth of screen space, and we're not summing them. We're only picking, sort of a subset. And so that's where you get that kind of unsmooth look. As we zoom out further, we get that sort of crispiness. And again, I don't know if you can see it, but trust me, the end user would see it on their when it's actually being rendered and isn't getting decimated by, say, a video codec like it is on Twitch, right? And so there's, first of all, that's a video quality issue. Now, granted, right now we're running through MSAA, probably a little unnecessarily. I'm not sure we really want to be running through MSAA as long as we actually are. I think we might want to separate into a 3D pass that goes through MSAA and then the rest doesn't, kind of a thing. But again, those are more for when we go to optimize the renderer. The only reason I bring that up is that's one of the reasons this doesn't look as bad. So right here, you can kind of see maybe that's around the natural bitmap size. Hard to say exactly what it is, but something like that maybe. Once I get out to 2x, like about there, I would expect those sparkles to start being pretty noticeable, and they're not that bad. Part of the reason they're not that bad is because we're still running through MSAA, and I don't know to what extent we're getting some benefit there, because I think we have some kind of alpha to coverage stuff turned on. I can't quite remember, but it's been a long time since we've played around with the rendering stuff. I think we're basically leaning on extra performance in the graphics card to fix the problem in terms of sparkles before it even, so it's making it look not as bad as it should look. And we're basically wasting GPU time for no reason to do that. Because in the future, like I said, I think we can optimize our render quite a ways from where it is right now. And that'd be one of the things we'd want to do. And then I think this would look even worse in terms of those sparkles. So there's that. So we got the lighting, we got the MIP mapping, and the MIP mapping actually has other issues that may or may not play in here, and I don't really know because we haven't really tried to analyze it at all. But one of the things that also happens when you're not using MIP mapping is if you don't supply MIP maps to the graphics card, it means the graphics card always has to sample from the most detailed version of the texture because that's the only version it actually has. What that means is that it will do a lot of scattered grabbing for bilinear from that texture, which pulls in a lot more memory bandwidth-wise through the graphics card as it's doing that sampling than was really warranted. It didn't need all of that memory because it was really just trying to get a much smaller image worth of samples. But since they're all spread out over this big texture, it creates this sort of nasty memory bandwidth problem where you're forcing a lot more bandwidth through the card than you actually needed. And so one of the other nice benefits of adding MIP mapping into the system is that if you provide MIP maps to the graphics card, not only should it generally look better because it will be able to sample more accurately what's going on, but it should also reduce the bus bandwidth on the actual graphics card because more of the actual data will get used because, again, it can pull in the whole MIP map and use all of it to do its rendering, and that will be much smaller than pulling in like a whole chunk of a texture just to sample 4 pixels out of it, then a whole nother chunk just to sample 4 pixels out of it, right? And so the number of texels that you end up using per sort of cached line that's pulled in across the bus into the texturing, into the shaders, right? That savings adds up typically. And how much it would add up for us, I don't know, but point being, that's another big reason why, certainly depending on the system, it always is dependent on the graphics card and how big the cache is and how much textures you're using and all that stuff. But it's usually, the one thing I could say is it's never better to have these giant textures sitting around if you're only actually rendering these little tiny pieces of them. At the very least, you could just send down just the tiny version, right? So I think we want to address that as well, and that's just another, again, visual quality thing. Finally, the last thing that we probably want to look at is a better distributor, and that is to say that if you look in here, you kind of just have random clumping. This is what's called white noise. It's the kind of noise that's actually entropic, the kind of noise you're looking for in, say, cryptography, unpredictable. And so that kind of noise in terms of scattering things around in a natural way that's the kind you would see in nature is not really appropriate. Typically, things don't like to clump close together in nature. They compete for resource if they do that, so they tend to spread out. And so the kinds of patterns that we see in nature tend to be more like blue noise, which is noise that is filtered to prevent two things from being too close together. So it's still random, but it has constraints on the randomness. And I've talked about that before, and that's obviously something that you would want to do here. We want to probably look into something like that. And furthermore, even if that wasn't sort of something that we would take a cue from in nature, just in terms of rendering efficiency, you can tell that that would be interesting to us because we're trying to cover the ground with a certain number of sprites. We don't want to have to place an infinite number of sprites down here to try and get good coverage. So spreading them out in sort of a natural, so that no two are particularly close together, is also just a good way, in addition to sort of mimicking what nature would do for resource competition, it's also just kind of a nice way to make sure that we get a good even coverage, which is something we would want even if that wasn't a natural look. We may just want to do it for rendering, right? Excuse me. All right, so that's where we're at, and I don't know how I want to attack this problem exactly. But I think what I'd like to do is I'd like to just maybe open up a couple weeks here where we're just going to start working on our rendering quality, and we'll just do whatever we want to do. So we're going to just work forwards and start to pick things apart and try to get to a point where we feel a little bit more, where we're feeling like it's a little bit more towards the completed version of the game renderer, which we're getting there. So I would like to maybe make that a push for that over the next few weeks as we go. All right. So I think the biggest thing I notice right now that we can take care of immediately is that the creepy crawlies that I'm seeing here with the MIP mapping, I think today we should be able to, unless we get into graphics sort of GPU hell, if you will, I think we should be able to do something about that. So I'm going to go ahead in there and try to just take care of that quickly. And then I think we want to move on to getting some sort of working on the lighting, which I think will take a longer period of time. So how do we work with MIP maps, and what even are they? Let me give you a brief sort of overview. We've talked about it briefly before. I'll talk about it briefly again now. It's not a particularly complex issue, so hopefully it won't take too long to sort of give you the background, but I just want to make sure everyone's on the same page of what's going on here. All right, so MIP maps. So MIP map is actually an abbreviation. You may have not have ever really heard what the term stands for, but you probably heard the term. MIP is actually not, it's not like there's a processor called MIPS, right? It's not the same. These are different acronyms. The MIP in MIP maps actually stands for Multum in Parvo, I believe, right? Which is Latin for many in place. I believe that's what it actually stands for, but I don't speak Latin, nor was I around when they invented MIP maps. So who knows? But that is an accurate way to describe them. Multum in Parvo, many in one place. That does actually tell you what a MIP map is. What a MIP map is storing more than one version of the same texture map so that you can do sampling on it more easily. Now, the kind of MIP mapping that we have in modern GPUs is what would typically be called pyramidal. I'm not going to spell that right. Pyramidal, I don't know. It's called pyramidal MIP mapping, and what that basically means is we're going to build what amounts to a pyramid of textures, and each layer of the pyramid is used for sampling at a different distance. So, what is a MIP map? Well, we all know what a texture is, right? And a texture is just a bitmap in memory, and maybe that bitmap is like 256 by 256, right? You may ask, why are they square, right? And actually, MIP maps is one of the reasons they are square. Basically, wrapping, like UV computation with wrapping, clamping, mirroring, and MIP maps are two reasons you want your textures to be square in terms of implementation efficiency in a GPU. But that's sort of neither here nor there. We don't care about that part of MIP maps right now. We actually just care about quality. So, a texture is some bitmap. It's 256 by 256 in this case. I'm just making up a number, but it's some dimension, typically a power of 2, also related to MIP maps. Typically square, also related to MIP maps, right? Okay, so what happens? Well, when we sample this texture, like I said, we are fundamentally asking the question on the screen, right? We have some pixels, and these pixels are in a grid. At any particular location for one of these pixels, right, I'm going to be asking with my texture map, as I try to draw shapes that have the texture map mapped onto them, I'm going to be asking what color would the texture have been here, right? If it was actually taken and put out there in the 3D world, and I was looking at it, right, what would it be? And to answer that question, as we know, we take what's called a bilinear sample, right, which is we take where this would actually be if this thing was here. We find out where that would be in the texture, right? We look at the 4 texels that are right in that area, right? Because remember, the point in 3D space is not going to correspond exactly to a texel. It's going to be in between texels somewhere, because this is a full 3D transform, full floating point. Who knows what's going on there, right? So we're going to be somewhere in this texture, right? And what we're going to see is that we're going to take the 4 texels that are surrounding that sample, and we're going to blend them together to get the result, right? And that's called bilinear filtering, and we all know all about that. If you don't know what I'm talking about, you haven't been watching Handmade Heroes, so go back, use the episode guide to search for bilinear, and I will teach you all about it. A past me will teach you all about it, right? And that's as far as we got. But here's the problem. Look at what's actually happening here when I take this texture and I try to place it somewhere out in a 3D world and render it to a screen with the projection. Well, the pixel is actually occupying a whole area that maps to some kind of a quadrilateral here in texture space, right? And depending on how small, like let's say this was actually the whole texture, right? Getting mapped to this shape on the screen. Well, this diamond area here, as it gets transformed back, is like this or something, right? And if this was 2D by 2D6, there's tons of texels in here. Look at how many texels would be inside this diamond, right? I mean, this diamond's almost a quarter of the texture, right? It's almost like a 128 by 128 diamond, right? And so if this is a particularly detailed texture with lots of complexity in it, sampling 4 texels isn't going to tell me jack squat, right? I mean, if I've got like, you know, some reds over here and a green area that comes in here and some checkerboarding in here, I mean, who knows what it is, right? I got to pick a single color to represent all those. I can't figure it out just from 4 texels. Depending on which 4 texels I randomly ended up closest to in this one centroid sample I happened to pick, right, is going to give me a wildly different result. So here's where that sparkle, I always call it crispiness, right? You've heard me say this. You know what? That's some bad spelling. Crispiness, right? So this is where that sparkle and crispiness comes from. As this slides slowly across the screen, this location that's picking 4 pixels is going to jump. Like if I move this only a little bit, like I move this a half pixel to the side, this thing's going to jump all the way over here, right? And it might pick a totally different set of 4 colors to sample from, and I get that sparkle, right? I get that sparkle. So the key thing to understand what we're trying to do here is say, how do we get 4 texel sample to give us back a more representative result of what the texture looks like in that area? And that is where mipmaps save the day. What we do is we say, let's pre-filter our texture map and store the results of having it scaled down a bunch of times. So instead of just storing our 256 by 256, we will then do a 128 by 128 and a 64 by 64, a 32 by 32, a 16 by 16, an 8 by 8, a 4 by 4, a 2 by 2, and a 1 by 1, right? And you can see exactly what I'm doing here. I had a 2 to the 7th, right? I mean, well, I started with a 2 to the 8th. I have a 2 to the 7th, 2 to the 6th, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0. This, as you can see, forms a mipmap pyramid, right? It's basically a pyramidal arrangement where I have a 1 by 1 that's just the average color of everything, a 2 by 2, which is basically like what the colors were in each quadrant, right? A 4 by 4, which is a 16 version of that, right? And so on and so forth. What this allows me to do is this allows me to say, all right, when I'm going to sample an area, before I actually go look up what the 4 texels are, I'm going to use the derivative in screen space of the UV coordinates of this shape, right? Because remember, it's the UV coordinates that tell me where to look in this thing. Remember UV coordinates, right? Well, actually, they go like that. Remember UV coordinates, right? They're telling me, it's how I map textures onto a mesh. I'm basically saying, pinning down where it all is, and I interpolate between them, right? Again, look us up in past Handmade here. I don't want to go through UV mapping again. Well, if I simply looked at the rate of change from pixel to pixel, right? The du, like d screen x, and the dv, d screen y. I don't know how you want to think about that, but basically, like, as I step from here to here and from here to here, right, as I go pixel to pixel, how much is my u changing? How much is my v changing? Those rates of change can tell me how large the texture actually is appearing on the screen. If those rates are very, very low, I know that that the texture is very large on the screen. If those rates are very high, then the texture is very small on the screen, right? So by comparing these rates of change to the rates to the size of the texture, right? And we can talk about that a little bit more in a subsequent stream. It's not really super relevant to us how the GPU is doing this because we're not actually implementing that equation ourselves. But someday if we do a software version of the renderer, we want to implement MIP mapping in that renderer, this is what we would have to figure out, right? The texel change, basically, versus the screen. You know, how many texels do you move if you move one unit in screen space? Okay? So what we would like is we would like to make it so that when we are sampling 4 pixels, we actually sample 4 pixels that cover the entire area this thing would have mapped to. And lo and behold, if we went down to like about the 32 by 32, or maybe actually all the way down, maybe even to like the 4 by 4, it's hard to say. That's almost a quadrant, right? If we went down to the 4 by 4, that's exactly what we would get, right? We'd be able to sample just that region. With 4 samples, we'd get all the colors averaged together, right? So what we do is inside the GPU, it sort of straps on a little piece that goes, wait a minute, instead of just reflexively looking into this texture, let's actually go to a little piece of logic here that says, go to the texture that would be most appropriate for these gradients, right? For these changes. Okay? And that filtering process basically allows us to leverage the fact that we have pre-applied condensation to each of these texture regions to collapse them into smaller and smaller pre-filtered versions, because otherwise the only other answer we could have is to actually sum up what's the entire contents of this giant region. That's way too much work for the GPU to do for every texel fetch, right? Summing up thousands of pixels potentially. All right, so this is a great solution to this problem, especially for us, which we're doing sprite rendering. Let me just mention briefly the concept of anisotropic filtering. You may have heard this before. Anisotropic filtering is an extension of this, and it solves a problem that we don't have, really I don't think we're going to have much of. Well, our walls could have it. Our cubes could actually have it. But so let me just mention what it is, and so that you're aware of it and how it relates to this. So one of the things you'll notice here is if I take my screen grid, like I was saying before, and I'm saying this is, I'm trying to sample a pixel here. Well, what I just said, all of this works very well if the texture is relatively head-on to the screen. But what happens if it's very oblique to the screen and only on one axis, let's say, right? So, what if I had something where I had my texture was like getting mapped onto something that looked like this, it was laying down. And so when I look at where this thing maps into my texture space, right? If this is the upper corner here. If I look at where this maps in my texture space, you can see that towards the top of the texture, I'm basically using almost the entire thing, right? But towards the bottom of my texture, I'm using very little. I'm using less than half even, right? So by the time it gets down to here, I'm maybe looking at like that much, right? Well, what you can see is happening is I'm producing a trapezoid, right, in my texture space. And the problem with a trapezoid is you can see it very visually. The number of, the Mipmap that I would want to sample to compute this line is like the lowest one or close to it. It'd be like the 2x2 probably, right? To sample that one. Because I want something that looks like that. Because I got to take, I have one texel. I'm trying to sample this entire thing, right? This one, on the other hand, maybe wants to come from the 4x4 or the 8x8, right? And so the problem you have here is like a mismatch. A single pixel wants to sum something that doesn't actually exist in the pre-filtered version, because our pre-filtered version just assumes that everything's like head-on, and we're subsampling everything with that, rectangular filter downward, assuming that we always collapse uniformly, right? And so what anisotropic filtering will try to do, it's a more advanced feature of the GPU, it will sample from a few different mipmaps, right? And really, you can implement your own anisotropic filtering in a shader too, because you have control over these now. You might want to do something crazy where you say, oh, okay, so I see that I map to this trapezoid, so I'm going to sample like some points like in here, and these are going to come from different mipmaps than these, and I'm going to take one in the center, right? There's all these different ways you might imagine trying to sample your mipmaps to try to approximate what the answer would have been if you had pre-filtered your texture in a trapezoidal fashion for being laid down in this sort of head-on, like very oblique fashion, right? But you can see why that's really hard, because once you start to talk about arbitrary angles, these pre-filters, I mean, I call it pre-filter for a reason. What you're doing is you're applying a more expensive filter, right, sort of beforehand, and caching the results. I mean, that's what this is, right? This is an exercise in caching. It's saying, let's use a little bit of memory to store the results of doing much more heavyweight filtering than we could afford to do at runtime for every single fetch, right? And so what happens is that pre-filter has to make an assumption about how you need the filtering to work. If we didn't have to do that, we could just always filter exactly correctly. But again, too expensive, takes too many samples. So you have to make a guess here, and this is as good a guess as any, right? Just decimate by 2 each time, store the results, and hope that that's going to work. But you're going to get cases where it's not very correct. And so what anisotropic filtering and other sampling schemes that try to like pick from mipmaps in an intelligent way based on the trapezoidal, it doesn't really have to be a trapezoid either. It could be something else, right? Because you could get, it's a quadrilateral, right? You know what I'm saying? So that quadrilateral in texture space informs how you might want to take your sampling and go. Now, when I say quadrilateral, it's really not a quadrilateral, because you're usually sampling potentially multiple points. Like you let's just say this. Sampling theory is its own thing. Let me put it to you that way. So I don't want to like browbeat you into thinking it's got to be a quadrilateral because a pixel is a square. You could think of a pixel as a circle for filtering purposes as well, in which case it would be some kind of an oblong, like an eccentric circle, right? So I'm not really a sampling guy, and I don't want to impose any sort of preconceived notions on that. So I'm simply going to say it's a shape, right? What you are trying to do here is map the shape of a pixel into the texture and sample that shape in a way that sums what's inside it in a good way for producing nice, pleasing visual results. There's a lot more theory in there, and I'm not an expert on it, so I don't want to say things like quadrilateral or ellipse or whatever and act like I'm saying that that's the only one, because it's not, right? You can have arguments about what pixels, are pixels little squares or aren't they, and these sorts of things. And those are things that are not really the kind of stuff that I tend to work on, so I don't have strong opinions about them, and I don't want to make it sound like I do. But anyway, no matter what you think of as the mapping there, you're mapping something into that space, and the question is, how do you accurately represent what the texture would have shown if you could do like an infinitely good summation of everything that was in it and so on. And it gets into all kinds of details too, like what does a texture really mean? Because a texture itself is a sampling of something. it's not infinite resolution. It's individual little points where you've recorded the state. How did you record that state? What do those things mean? Are they normals? Are they colors? Are they reflectance? Are they emittance, right? How you might sample them may even depend on what's actually in them, right? And so all of that comes into play if you want to go beyond just the basic thing that we're doing today, and probably in Handmade Hero at all, which is just we want our filtering to be smoother, right? That's all we're looking for here, smoother. A nice approximation of what happens when things scale down. And again, you can already see, now that I've sort of shown you how this pyramid looks, you can see what I meant as well about saving memory bandwidth. If this thing is going to sample out of here, remember I said as I move it, it's wildly jumping around kind of where it has to sample from. When it's only looking at this little 16 by 16, it can pull in like maybe just one cache line through the graphics card, tells it everything it needs to know to render that entire sprite, potentially, right? That's just a huge savings compared to having to like jump all around randomly, just based on happenstance where those pixel centers end up, pulling in segments of the, because the textures get pulled in little blocks, right? It's touching all of these blocks to compute a worse result than if we just pulled in a 16 by 16 and got a really good result, right? So again, MIP mapping, very, very, very good, especially for what we're doing where we tend to have things that are mostly facing the camera anyway. It's the exact right solution for us, and it's absolutely what we want. So what we need to do is not much. The graphics card already has most of this stuff built into the texture unit. You don't even need to implement the shader yourself. It's actually something that I think happens during textile fetch a lot of times. I think the bilinear, there's actually a lot of cards just have bilinear textual fetch hardware that does it specially. Don't quote me on that because they may have gotten rid of that by now, but they used to anyway. And so it's even faster to do basic bilinear mipmap stuff than it would be if in our shader we were manually grabbing things and summing them together. Because I believe they've got like hardwired bilinear collapsing stuff right on the texture unit to give you this increased throughput for that default case. So that means we can do very little work. We don't even have to rewrite our shaders or anything. All we need to do is just tell the graphics card, here's those things you wanted. You wanted those box filters versions. You wanted the 256, 128, 64, 32, right? That's what you wanted. We got it. Here it is, right? So we just have to start supplying these MIP maps. And once we supply the MIP maps, the graphics card can take care of the rest because it has special hardware to do exactly this. We don't even really need to implement anything in our shader. So let's go ahead and open up our code and get this going. Now, if you have been with us the whole time, if you're a Handmade Hero diehard, then you know that actually we have some calls in here that are like text subimage, and we call this, right, in here, you can see it, when we're actually transferring stuff down to the graphics card. I believe this is it. Yeah, here it is. So in our Manage Textures call, you can see we've got a special texture path that happens for weird rectangular textures that are used in cutscenes and stuff. But most of our textures go into a texture array, and here it is. We call GL text subimage 3D because it's a texture array, and we attempt to put something into the texture, right? And this allows us to transfer, using our texture index, into a particular slice of a texture array, what the width and height are for that particular thing. Now, you will notice there's a bunch of zeros here. What do they all mean? Well, if we go over to docs.gl, our favorite place for, in fact, why isn't this, can we get that up in here? Yeah, all right. If we go and look at text image, text subimage 3D, and we take a look at the documentation for it in GL3, which is what we were using, you can see that there's a bunch of parameters passed here, and at the beginning we have a bunch of zeros. 0, 0, 0, texture index, right? 0, 0, 0, texture index. Z offset is where in the slices we are, right? Because remember, we put all of our sprites into one texture, and we just use slices in a 3D texture for them, right? It's called a texture array, very common for bitmap games, right? X and Y offset, those are both 0. Those are those zeros right here and here, because we're just putting it in the upper corner. We don't do anything else with our updates. We don't pack yet. Maybe we should. We're wasting a bunch of space, so someday maybe we will. But this is the one I really want to talk about right here. There's a 0 at the beginning of our GL compressed text subimage 3D call, and that 0 corresponds to this. This is what this is. Each one of these levels is each one of these mipmaps is assigned a level number. The level number is the power of the texture. You would imagine, where's my pen? I want to draw it. That level number just corresponds to where in this you are via the equation to the whatever the dimension of the texture actually is minus the level. Okay? So if we have a 2 to the 8th texture, right, then this d equals 8. The levels of the texture are d2 to the 8, are d8 minus l, right? So level 0 is our 2 to the 8th texture. Level 1 is our 2 to the 7th, right? Level 2 is 2 to the 6th. And so as the levels go up, eventually you will get down to a 2 to the 0th texture, and that's the last level you can specify. So in our case, we can specify 8 of these textures, because 2 to the 8 minus 8 is 0, which would be the 1x1 texture, the last one we could actually specify, right? And so that's the ball game, folks. So that's what we're doing. So what we want to do is effectively extend this call. Like, this is our problem right here. This is why we aren't getting mipmaps. We aren't specifying all the levels. So what we really want to do is something like this, where we say, level index equals 0, level index is less than 8 or something, and, we got to go calculate what this is. Level index is less than or equal to max level index mac OpenGL blah. I don't know what this is because we haven't made it yet, but point being, this value is going to be something we specify based on our texture size. And then this has to specify some kind of set of data for each one of these, right? And so this is the extension we need to make. That's what we're missing. Once we provide that, then we can just turn on MIP mapping and it will work. Done. Right? Okay. So that's the first thing we want to do, and it's going to take us a little bit of work. But let's try it. So what I want to do first is I'm going to do... we need to basically create space to store these things, and we need to know how many there are and all that kind of stuff. So we need to start extending our texture pipeline to allow us to provide these mipmaps as we go. Now, there is... How do I get this here? There it is. There is a thing called GL Generate Mipmap. And what this does is this will generate them automatically. It generates mipmaps for the texture attached to the target of the active texture unit. And the only thing I don't know is how reliable it is. So we could, another option is to just call it and call it a day. It's less work. I just don't know if it works. Always. Probably. I don't know. I guess I'm tempted to just call it. The nice part about it is that if the hardware can accelerate building the mipmap, it will, and usually it can, because all it is a series of calls to the render, to the blit, to like sample them down. So we could, and let's try it, I guess. It saves us some time. So if we were to still call this and not actually submit them each individually, we would just call this function, GL Generate Mipmap, right? And that would be it. I don't think that's a default call, so we probably would have to provide it, but that's okay. And then what would happen here is this GL texture 2D array, we're just telling it that whatever texture you had bound to that slot, because remember, you got to bind these textures. So right here in GL bind texture, we've bound this texture array handle. That generate mipmap call is going to operate on this texture array handle. So we send the image down, then we say build the mipmap for it, right? Now the problem, here's the thing why I don't really know if that's a good idea. I feel like that would require it to generate the mipmap for the entire texture array, and I don't know if there's any way to tell it not to do that. So again, I don't think this is a good idea, I guess is all I'm going to say. If you called it with a 3D texture and you tell it to generate the mipmaps, I'm suspecting it will probably not keep any kind of dirty flag, so it will just generate it for the entire thing. We've got like 100 some odd textures in there. That's just really expensive. So I'm pretty sure we don't want to do this. But we can try it. And then I'll replace it with the better thing, maybe. Seems like a good idea? I don't know. So anyway, let's try it. We'll see. I don't even know if it'll work. It might just fail as well on two texture arrays. I don't know what the rule is there. It looks like cube maps aren't allowed, but it looks like texture arrays are, right? Mipmap generation replaces textile array levels base +1 through Q. What the heck is Q though? What is Q? 1 through Q. You didn't tell me what Q was. I guess I'm just supposed to remember from the spec what Q is. All other mipmap arrays, including the level base array, are left unchanged by this company. I have no idea where they're getting this Q from. The internal formats of the derived bitmaps all match this level base array. The context derives arrays. Yeah, so I mean, just looking at it, I'm pretty sure we can't really rely on this long term, though, right? And I think that's just because it's gonna cause it to, every time we update a single texture in our texture array, there's no way to say just regenerate this slice of the array. You know what I'm saying to you? And so I don't think there's necessarily any way to do that. What is this flag right here? See, that's more what we would like, because then we would know that when we updated it would just know to do that, but again, still not good. All this stuff just gives me the hives, because who knows what the card's going to do. Here's what I'm going to do. I'm going to say, forget it. I'm just not using it. I'm sufficiently spooked. We're not going to do it. We're going to send down our mipmaps manually, and that's just the way it's going to go. Be advised that function exists. If you want to play around with it, go right ahead. There's another way we could do this too, which is that we can use render to texture to basically create a, us do the blitting as we go. I'm not going to do any of that. We're just going to do this in software because this is Handmade Hero and we implement the stuff ourselves anyway. We might as well learn to do it in our own code. Okay? So that's just what we're going to do. And I don't want to know what the heck is going on there behind the scenes because I don't trust it. I never trust a graphics card. It always screws me. All right. So what we need to do now is just say, okay, when we load stuff, we need to be able to generate the sort of the scaled down versions of things. And thankfully, we have worker threads dedicated to exactly this. So we should be able to have a little simple downsampler, like we've already written something that scales images down by 2. We should be able to create something that will just take the bitmap, scale it down by 2, scale it down by 2 again, scale it down by 2 again, and just keep all of those results so that we can, after we load them, just submit them, right? And it's not clear to me that maybe we want to actually store the mipmaps and load them in, but it's not clear to me that that's a good trade-off because we probably, as the further we go forward in computing, the more often you've got cores sitting around that could be doing work for you. And so why put more stress on the hard drive throughput, which oftentimes is limited, when we could just dedicate a core to decompressing and collapsing things and so on. So I would say probably my guess is let's just use a core for this. That's my thinking. All right. So in here where we do load asset work, you can see where we've got this work texture op thing, and we call complete texture op on it. And so in this platform work queue callback, what I would like to do here is after the read data from file, if we assume we need to do mipmaps, something like this. If it tells us to gen the mipmaps, then what we need to do is go through and gen the mipmaps. So this right here is going to be a thing which would do that MIP generation. And what I would want to do is we're only going to do this for square things that are power of 2, right? I guess technically we don't care if they're power 2, but we do only really want to bother with them if they're square, I guess is what I would say. And we kind of want them to only be power of 2 too. I want this thing to be square power of 2. I don't want to deal with anything else. Let's put it that way. Okay, so let me look at complete texture op here. So the only thing that's a little wonky now that I think about it is that when the width and height come in, we actually don't bother, we don't pad it out until kind of later in the process, right? So that makes it actually a little bit trickier, a little bit more tricky, because it means that we don't have things that are quite a power of 2 yet either. So what we would like to do here, I guess, actually is be able to fuss with these in sort of a way that just adds the padding as necessary on each downsample, which is a little annoying, but oh well. So what I would like to do here then is, I guess, just do the downsampling without that, right? Don't assume that it's got to be padded or anything like that. Just do a real downsample and then upload the stuff. So if that's what we're going to do, excuse me, then each time we do the bilinear, we may have to expand by a pixel if the thing was not a power of 2, which is not going to be most of the time. And so that's going to be a little bit delicate, and we have to make sure to get that right. So what I'm going to do is, because I might need to do this sort of same stuff in multiple places, I want to create a helper function and assume that I have something that can give me what the correct operations are to do as I step down my mipmap levels, right? So what I want to do here is say something like MIP iterator, right? Like this. And say begin MIP on this thing. It is going to require texture op. The texture op itself has the texture handle in it, excuse me, which tells us the width and height of the thing we need. So basically what we would do is say work texture op texture. We need that, actually, sorry, it's a pointer. We need to get the width and height out of that, which we've got a thing from somewhere in here. Or do we? Do we just use it just like dot width and dot height? Maybe we just actually just access it directly. Yeah, all right. So we know the width this way, and the same with the height, right? But actually, I suppose we probably just want to do it that way, because we're always going to have that texture handle available, probably. So maybe we'll do it like that. So we'd say, look, begin a MIP series for this thing. Take the width and height. I'm going to assume that whoever you are, you know how to do everything, right? So this little iterator doodad here will just create the right set of like power of two things and whatever else needs to happen. It'll work for us sort of doing our downsampling, right? And then for each part here, what I need to do is I need to have our box filter or downsample, there it is. I need to basically have this thing, and I need this to be able to downsample by 2 each time. I need to call this on each one of these. Now, what I'm not sure I understand, looking at how this thing works, is this thing assumes that everything is a power of 2, right? So is everything actually secretly a power of 2? Right? I mean, you can see that this totally assumes that. You know what I'm saying? Because it's always going to grab 2 for every one. So I guess I lied. We do require everything that comes through here to be a power of 2. Yeah, all right. Well, that keeps it simple for us. Less efficient, but simple. So if that's the case, then we already effectively wrote all this code. Right. All we're going to do is just be doing this downsample, and the only real change is we probably want to make this downsample take to a source and a dest, and you can pass the same source and dest if you want. And in our case, we would pass different ones because we want to downsample and save each version of our downsample, right? But that's basically all we'd be doing. So this downsample would just get called here, and it'd be called for every step through the MIP, and that'd be that. So I think that's all we really want to do here. And looking at the texture op itself, so when and in fact, I think I can kind of see also how I want the rest of this stuff to work here. If I look at that texture op, just looking at how this goes, maybe what I want to do is pass this directly. So I think what I might do is make the MIP operator here actually just take the texture op. So you say like begin MIP and you get back this MIP here. And then what happens is on each call through, I'm going to like downsample from one of them and into the next one, right? And so on the first time through, I don't actually want to do anything, right? So on the first time through, I just want to advance the MIP. But before I do, I want to save the sample, like the source, right? So what I want this thing to do is give me back like that region from the texture op that's actually got the data in it now. And then what I'm going to do is advance it forward. And so then in here, this is actually becoming a while loop. I'm going to do, oops, this. And each time I go through and do my advance, in fact, I guess I could do, well, no, I'll do it like this. Each time through here, I'm going to go ahead and take the dest, like so. I'm going to downsample from the source to the dest by 1. And then I'm going to advance the MIP forward to the next one. And I guess each time also I want to update the source, right? So just going to roll through these, updating the MIP every time, and downsampling, right? That's really all I want to do. So I want this like begin MIP thing to just be able to, or like iterate, maybe iterate MIPs. I want that to do the work of keeping everything lined up. Now, you may ask why. Like, why did I do that? Doesn't really make any sense, does it? But it does make a little bit of sense because remember, we're going to come in here next. And this thing wants to do exactly the same thing, right? So what I wanted was this. I can call exactly the same set of source code here. And then I'll know that the thing that generates the MIPs is generating them into the exact same set of pointers as the thing that actually submits them, so I can eliminate the possibility of having bugs between those two updates, right, between those two walks. So again, just defensively programming it myself so that I know that the failure is all in one place, so when I debug it, it'll work, right? Okay, so as I do this submission, I'll also have a level parameter in there, I guess, like that. And then what I can do is say, well, when we're doing the texture submission here, this width and height are going to change each time, and so I want to do this. Right? And I think that's all she wrote. Can't remember what this is called. It's like pixels, data? I don't know what. Who knows? I really don't know. Something like that. Let's take a look. Pixels. So you can see that's all I was trying to do. This way we write one iterator. We can use it to submit our stuff because it'll tell us the width, the height, and the pointer correctly. And we'll throw the level in there for good measure. And then we can also do, when we're actually doing our downsampling, we can use the exact same thing. And we know that they have to line up. So once we get one of them bug-free, the other one will be bug-free. Famous last words. This is calling OpenGL, so not necessarily. But, closer to bug-free. Okay. So what we need now is a downsample that takes a source and a dest. I actually have a pretty good idea of how I want to do that, and that is to say that if you take a look at this call here, this is doing a loop. I don't want it to do a loop. I want just a single thing that actually does the downsample. So what I'm going to suggest is that we have another version here called downsample that does this, which is the one we actually want. And what that's going to do is it's going to take these here and it's going to just use this part, just that. All right, that's all it's going to do. You know what I'm saying to you? And that way, when this thing does its little happy dance, it's going to pull from one and write to the other, which is more what I wanted. And this thing can still use it because since we know that it works in place as well, we don't need to write two versions of the same function. So what we can do here is say, all right, we know we've got the result here, which is this one. What I can do is just save that before we reduce it. So I can say image u32 sort of like dest equals Or I guess I could say prev equals results. Something like that. And then here, we just do this. So the idea here, right, is we would just be taking, we don't need this. We would just be taking, when we do our downsample, right, we just take, okay, where are we at right now? Remember that, because we're going to need that in a second. Take the place we're at right now and decimate by 2, right, shrink it by 2, and then pass that as the dest. Calling this will do the same thing it used to do before, like this. And so all we now need to do is make sure that this function actually pulls from source or dest correctly. So in here where we've got dest pixel, we actually want dest.pixels. In here we want source.pixels. Here where we're grabbing from the source, we want to do source.width to advance it because that's the one with the correct width in our case. When we come down here to do dest pixel packing, we don't have to change anything because it's just writing off the pointer. And similarly here, we want to go back and use that source width again. And that's it, right? That's all we needed to do. So I think that should keep us completely compatible and everything should work. The downsample by 2 can now get pulled out of the import stage and into something that's actually just like a math library or something like that. I don't know where image U32 is actually. Where the heck is image U32? What's it doing in here? In the ping code. All right, whatever. Anyway, so I don't know exactly where this would be. Maybe in the shared code. I don't know. I really don't know where downsample by 2 should live. It's kind of a image operation, but we don't have image operations in our system right now. So I guess I'll just sit here for a while and hang out. I don't know. Oh, well, you know what? It probably should go where all the rest of this stuff is. So where's like BGRA impact? Where's that at? Looks like it's in the renderer code. Yeah, I don't know. Interesting. Where is this? So I guess this version of the editor is too old to have file info. Anyway, so in here, well, I guess I can just do this. It's in handmade math.h. Is that an okay place for it? Image 32 is not there, though. Maybe I should just make a new thing for it. I really don't know where this should go. We don't have a place for this sort of stuff. You know, we don't have an image set of things. Maybe I'll just put it in the PNG library, and that's where all the rest of our image stuff is. I don't know. You got me. It's there now, though. All right. So we're just going to call that a day, because I don't care. And so now we've got to get back to some of the more subtle parts of this. So first off, we've got to make our actual MIP iterator stuff exist. It doesn't right now. So we need to define this somewhere. And so I suppose that this should be something probably in the render stuff. Let's see, probably handmade renderer.h. So we want to kind of introduce this thing as something that's like struct MIP iterator, like so. And you know, the image U32 should probably be in here too, shouldn't it? Right? I mean, that's, I feel like that probably should have been in the renderer. I don't know. We kind of have a problem where this stuff needs to be shared, so we might need to kind of pull it out into a separate thing. Like, you know, if I were to do that, I'm not sure, yeah, like PNG parser and stuff gets upset because it doesn't actually have that, which is an issue. I don't know. All right. I kind of want to make like a little image library thing. It's sort of what I'm feeling we need to do here, but I don't know. So all I'm going to do here is just stub these out. And then we'll figure out how to implement them in a second. I'm also kind of want this to not be where my head is. All right. So we may need to unpack the texture ops thing there a little bit, but that's fine. And we'll deal with that in a second. So let's see. Yeah, so this stuff, the problem is the renderer doesn't know about the PNG library because it's kind of isolated in that sense. And so I don't know if like I don't know if that makes very much sense, right? It doesn't seem like that should kind of be in there, right? And yeah, this doesn't have memory arenas, for example, so that kind of pollutes that again. So I don't know. It really does kind of seem like this wants to be its own thing. So I think I'm gonna bite the bullet. There's just gonna be a thing called Handmade Image that just has this stuff in it, and that's all. And everyone does it, right? So there's a new file in Handmade code called handmadeimage.h. It's going to have that. And it's going to have this. And it's going to have this. And maybe there's some other stuff that we didn't put in here that should be in here, right? So we might go ahead and kind of move some more stuff into here as we go. I don't know. It's kind of a good question as to what we want to do there. I don't really know what we want to do there, but something along those lines. So then what I'm going to do is inside Handmade OpenGL, we're going to include that and oops. And I also guess, I don't know where the CPPs get included here, but we'll put those in here as well, I guess. Because we'll want that. Our test PNG code will now need this. Something like that. Actually, that just means those are in the wrong order. That's an HH font. There we go. By the way, 100% of the stuff I'm doing right now is just because the C++ Standards Committee never knows what they're doing. Just to be clear. None of this should be necessary, even a little bit. But, you know, they only had 30 years to fix the order of declarations problem and never bothered. So thanks for that. Glad you have our backs. All right, so let's go into Handmade Hero now, and let's actually include these folks. Don't know exactly where we should include them, but, you know. I think we're good now. All right, so now I think everything's all set. And the only thing I really need to do is make a cracking version of this that translates the texture op request into a MIP iterator request here. And we don't really have to do that, but I might as well, so they both get done in the same place. And so what I want to do here is say, look, the call to iterate MIPs that you actually call here expects you to pass like various stuff to it, like the base pointer for the data, the width, and the height. That may be all it really needs. Yeah, I think that is all it really needs. And so this thing's job will just be to sort of crack that out into these, right? And that'll be fine. And then we'll implement this in terms of those sort of unrelated elements. Okay. So that's all I really wanted to do there. And furthermore, if we want to, and I guess there's really no reason not to at this point, this call right here could just be like generate local mipmaps or something. Like, you know what I'm saying? Like this right here could really just be something that we call directly. And maybe that argues for not needing this particular other version of the generate mips call either. So what we would do is we'd say, okay, you know, here's the texture, there's the width, there's the height. I don't remember where the data is on this particular thing, but I think it's like there. And off we would go, right? And so here we've got generate sequential MIPs, same call. And this would just do this, right? So here we have an iterator version. Like this is basically just a little really crappy image library now, right? We can scale an image down by 2. We can iterate over the mipmaps levels for something using correct pointer movement and stuff, which we'll implement in a second. And then we can also do our generate sequential MIPs call, which is just a utility that does exactly what you want it to do, given a set of pointers to it. So I think that's good. And then over there in the OpenGL side of things, where we're actually submitting it, I'm going to say, like, okay, since we only now have one of these, I don't need to make a utility for it. It's just going to call it with the unpacked version of all the data, and off we go, right? Okay, so now I think we're down to just, well, I guess there's one other thing we can do that's not that. We need to fill out this stuff properly, and that'll produce one more call, which is to figure out how much memory we need for a mipmap, so we might as well do this as well. So in here, I'm just going to add a thing that's like gen mipmaps. We don't really need an entire bool for it, but we don't really care about the memory that's used for this. Load asset work is not something that gets allocated very often, so it probably doesn't really matter one way or the other. But for now, we're going to actually flag it just in case. We're going to say if we need to generate the mipmaps, then we do, and that's really it. But that means somewhere somebody had to actually acquire enough memory to actually transfer these mipmaps, right? And so in here, we need a thing that's like gen mipmaps equals true or false, something like that, right? And so the question is, how do we know which one we want to do? And based on, you know, we need some information about whether or not this thing's supposed to have mipmaps or whether it's not. And if it is supposed to have mipmaps, we need to generate more memory because when we reserve space for it, it needs to have space for all the mipmaps as well. So what we're looking at here is something that's maybe a little bit more like this, right? Where we're saying, look, when we begin texture up, we kind of need to know whether or not it should have mipmaps, that sort of thing. What I would say is passing forward might not be the best idea. Could be that the texture op itself maybe should be recording this particular piece of information, and then we just look to see whether it said it wanted mipmaps or not. That seems like a potentially valid way to do this. And so I might suggest that's the right call. If you look at what's going on here, I guess what I'm saying is that may be what I actually wanted. And if that's the case, then we wouldn't put that here. It would actually be this thing that determines it, whether or not it goes in there and how it's going to operate. I think that makes sense because the render is the thing that really tells us whether it wants mipmaps or not, and maybe you want mipmaps for everything. I don't know. It's hard to say. Point being, let's just say that Gen Mipmaps comes back on that line. If that's the case, then the work doesn't actually have it in it. It's baked into that particular texture op, which means that this check right here would actually go here, right? This complete previous writes before future writes. I do wonder if maybe we need to make sure we complete all our work before that. I haven't analyzed that path through the code much, so I might say we should just do this just to be safe. That kind of thing. And then what we would do is just generate the sequential MIPs here as necessary, right? So that would mean that the texture op, when allocated, tells us whether we gen the MIPs or not. We don't actually store it anywhere. We just kind of do what it says. That means when you call begin texture op here, what it would do is, and I think we already kind of know, right? Which is that we want to know whether this one's going to be special or not. Like, is this thing going to be a special texture or isn't it, right? And so inside this texture op thing, when we actually go to create it, what I could do is this thing, right? So when we ask whether something's a special texture, let's see here, is special. So to begin honest, I'm not really sure when that determination actually got made, but if you look at a texture op, the texture op has the texture in it. Am I wrong about that? Yeah, the texture op has the texture in it that you're going to use. So when you actually get that texture op out, this part here, I mean, that's going to tell you everything you need to know, right? I'll be honest, I don't really remember how we were assigning those. So our texture op texture yeah, it gets assigned right here in refer to texture. So I think that's it. I think that's all there is to it, right? So I want to say that the best way to do this is just to, yeah, when we call begin texture op, the renderer is free at this point to say what it wants to do and what it doesn't want to do, but I think all it really should do is say, is it a special texture? If it is, it doesn't want mipmaps. If it's, and that's it, right? So when we come through here and we do this texture op result, and by the time we get down to the bottom here, we should have one, right? And it's going to return it. So at that point, we just want to do our check. But of course, the problem is it gets assigned there. All right, so never mind. I say. So this is a little more complicated, and we do have to pass it down here, right? like this thing needs to know, because it needs to be able to produce the right size for the transfer. Looking at this, so I think this is what I want to do to clean up this, the way this is flowing. So if you look at width and height, it actually is only used to create the transfer partition here, right? And so I think what we want is actually this begin texture op should just take size requested. So what we want to do is in here, we want to do a size requested, and we want to pass down size requested, right? This will not be computed here. It'll just say size requested. And we need to know, do we need MIP maps? Right? If we need MIP maps, then we need to create a size requested that has room for all of the MIP levels in it, right? That's what has to happen. And we would update our size requested to contain that entire set of texels, right? Now, we could create that closed form. I'm not actually even going to do that. What I'm going to do instead is I'm going to produce size requested by actually looping over in the same way that we were doing before, because I don't mind spending that extra speed to make sure that we always compute a completely consistent result. Okay, so I want to do it like this, where we say, let's ask first if we're going to generate mipmaps, and that's a call that this actually thing was already doing. So we can do that pretty simply. Then what we're going to do is when we do the rest of this stuff, right, we do get total size for MIPs, we would pass down the width and the height in there. In fact, let's just do that. We know we need that. And I think then we're good to go, right? So what I'm going to do here is inside acquire texture handle, that's where we're determining whether or not we would do it. So we're calling this thing here where dimensions require special texture, right? And so that, I'm just going to pull that call out. So when we do the acquire texture handle, we're going to pass in whether or not it's special, right? And so this particular call, right, dimensions require special texture. That is sort of the opposite of gen mipmap. So, you know, we could just say like special. Like so. And we know we want to generate mipmaps. Well, in fact, I'll just leave it like that. When it's not special. Make sense? And so, yeah, I think that's all we really needed. All we really needed. Then when we call begin texture op, we pass the size we're actually expecting to use, which we will have let ourselves created space for the mipmaps by computing that there. Then when we come down through here, when we're going to acquire the texture handle, instead of this like bit that we do here, we're actually going to pass down the special flag. So this just gets B32X special rather than ever doing the dims, right? And that's it. So that's all good. Then when we do refer to texture, it does this little bitmap with height thing. Refer to texture. And I think that's it. All right. Good, good, good. Starting to look much cleaner. Starting to look much cleaner. Okay. So now we just have to implement these. Begin texture op here in our example code. We know that that is just a size requested thing, right? This is our test renderer, so we don't really care about it, but you know, just might as well keep it working. Same here. So now, finally, after much massaging, I think we have gotten to the place where we can just implement our the actual logic that we requested and be good to go. Like I said, when we do get total size for MIPS, I actually want to do this so that we just loop. And that's just to absolutely ensure that we're using the same calculations everywhere. Even though we could use the power function and stuff to make it right, I don't care about the speed of this call at all because it won't amount to anything. So I'd rather not introduce the possibility of bugs, at least not at the immediate moment. So what I want to do here is just have an iteration, just like we would do in any other case, where we iterate the MIPS all the way down to the end of the chain, and each time through we just sum it up. Right? So that just produces a summation of all of the space we would expect to take for each one of these levels of the MIP, right? And then we just need to implement the part where we sort of advance and iterate here. And that should be something like, how do we want to do this? So that should be something like this probably. When we start out, we know the level equals 0. We know the image width equals the width. We know the MIP image height equals the height. And we know the MIP image pixels equals the data, right? The validity of this would be results equals MIP image width not equal to 0. I guess I would say. Would be the easiest thing. We could also do like a valid. Not sure how. I'm not sure what we want to do with that. We'll take a look at that after we do the next step. And advancing, well, some of it's simple, some of it's not. Obviously, to make the level go up, we increment it. Not very hard. In order to make the sizes decrease, we just divide them, right? And in order to advance the pixels, we just need to figure out some new value that should actually be. Now the problem that we're going to have here, actually I suppose I don't really need to do that. I suppose I can just do this. Right? Yeah. So the main problem that now we're going to face is just termination and how we want to consider, like whether or not we want to, or I should say how we want to consider the MIP levels to be terminated. So the problem that we're going to have is if we want this thing to work for arbitrary rectangular images, which we don't actually use right now, and so maybe it's just a pointless endeavor, but what we're going to have here is one of these two things on a rectangular image will bottom out before the other. So the width would bottom out before the height, or the height would bottom out before the width, and you would want to keep shrinking it down by 2 each time, leaving the other one fixed at 1, right? And so what you'd want to do is something like this. In that case. So if both of these things are higher than 1, then you're just doing a standard shrink by 2. But if one of these things bottoms out early, because let's say it was a 256 by 512, so one dimension bottomed out early, You don't want to divide it by 2 because otherwise you've ended up in a situation where you've got a 0 width or a 0 height image prior to the other dimension actually collapsing down to 1. But we also want to know the case where you have both of them equal to 1 because that was the end of the MIP chain. So what we might want to do, and I again just say might, is we might want to say, all right, look, if MIP level width equals 1 and MIP level height equals 1, then that's the end of it. Something like that, right? I don't know, not the greatest thing since sliced bread, but looks okay, right? Don't ask me why this has level everywhere. It's supposed to be image. Just a brain fart. Don't ask me why I'm doing this by hand. Probably because I'm in between editors right now. There. All right. So that's fine. What else we got? Okay. So I think that's basically what we want. I think we've done the plumbing, so now we just have to actually go through and make sure we've implemented all this stuff correctly, because I kind of spammed a lot of stuff out in there, and it's probably not going to work. So what I want to do first is I want to just switch to debug build for a couple seconds, go step through this code, and make sure I'm doing even something remotely related to what I thought I was doing, and get that going, right? All right. So let's start by looking at some of the submission process here. Let's try to make this stuff go. All right, so in here we're just doing our standard white pixel that's just used for making sure nothing actually happens when we do non-textured rendering. So that obviously comes through, and the size requested should just be 4 for a single pixel. 4. So that's fine. Let's double check now when we actually go to request some kind of a texture for actual use, right? So in here we've got load bitmap. We're passing down a particular ID, right? It didn't hit the cache, so now we're going to do something. So let's see what it is we're going to do. Here's the width that we asked for. Here's the height. That's what we'd expect. That's our standard sort of overly large texture. If we look at what happens here, we can see whether we got, special should be 0. So, yep, and it is. Gen Mipmap should therefore be 1. That means that the size requested, rather than being this, so rather than that, should be some other thing based on this total size for MIPS parameter that we came through here. But it's not. So we've already got a bug here. It's here, probably because I forgot to put a plus sign in or something. Yeah. Of course, that also means we've got a separate bug, because this should have produced a much smaller value if it was just using the last result. So we've got some other bug there too that's not working correctly. Yes, and you can see exactly what it is. These cases have been flipped. Okay. All right. So let's try again. Got some bugs out of there, and there we go. So jumping in here, don't care about that. We're going to look at that summation call now, where we do get total size for MIPS, and let's see if that goes up kind of as we would expect. So there's that first MIP level. That's exactly the number we would expect. Now it should go up by half that. I'm sorry, a quarter of that again. Looks good. Yep. Yep. Lovely. How many MIP levels are we expecting? At a 512 by 512, that's 2 to the 9. right? So we would expect this value, yep, to keep going. And you actually, this is nice. We can watch the width and height go down here. There's 4, 2, 1, and now we should bail, right? Now, I just want to make sure it actually summed the 1. So I'm going to run that one more time because I just want to make sure we actually summed the 1 and didn't skip the 1. So I want to do that, but other than that, that looked nice. So here we have summed the 512 by 512. There's the 256. There's the 128. So let's go all the way down. We've summed the 4, summed the 2, summed the 1. Perfect. So that's looking like it works exactly like I want now that we fixed our stupid bug. When I come back out through here, now our size requested should be a little bit more. There we go. And what you can see, too, is mipmaps don't take up that much space. You can see the difference between those numbers. It's not even twice as much for doing all that filtering. It's more like a quarter, again, the size there, right? You know? So not too bad of a price to pay for all this additional filtering. Just something to think about. All right. So when we go in here to begin texture op, we ask for that much size. Hopefully we get it. We then start our task. And we feed forward this stuff here. I'm assuming that we got the correct kind of handle because I'm assuming that we asked for no special. So that presumably is good. If I look at the texture op handle, I'm hoping that that's correct. It looks okay, right? I don't know how the indices work with special handles. Let's just take a quick look at that. It's got texture special bit set. Obviously, that's not true here, so that's good. And off we go. Okay. So that looks pretty nice. Pretty happy with that. Let's take a look at what happens now when we actually try to generate the sequential bitmaps part of things. This is not what I wanted. How did we get here first? Shouldn't I have hit my submission call? Who is getting submitted? Who got sunk this time around? Let's take a look. So we're getting an invalid texture format there, which suggests that maybe the, well, can't see this because it's behind my head. I wonder if I need to kind of move this over here. That's probably better, huh? Yeah. So if we take a look at what we were doing there, when we're calling this, it looks like it was unhappy about that. So the question is why? Like, what actually happened there that was bad? And I'm not sure. I would like to know what we were submitting. It looks like we were submitting level 1. So we were trying to submit one of these additional level bitmaps, but I don't know why. How did we get there, right? Because we didn't ever... Is this just our 1 by 1? What happened here? I don't know who actually produced this texture, but I want to. So this was texture index 1, and I want to see what's going on there because I don't understand. Did I not correctly set the texture op up for that somehow? Let's find out. I want to make sure that I'm actually calling our generator first. It shouldn't. That particular bug is not actually related to this, but it just, I was spooked by the fact that this gen mipmap doesn't seem to have happened. And so I'm wondering if we just, yeah, okay. So the problem that we're getting here is we didn't set that, right? I just forgot to do this. So we need to set that because I wanted that code. That's not the bug. right? That other bug is different. But the bug that I wanted to know what was going on is why we weren't seeing that call. I set a breakpoint, right? You watched me set that breakpoint in the asset system right here. It didn't get hit. It's because we weren't setting this value in the case where we do actually need to generate those MIPs. So I want to run it again. I want to watch that happen because that should happen before we do a MIP submission. All right, so in here now we're going to go ahead and do our downsample. So I want to watch this happen, and I want to make sure that this works properly as well before we, well, or at least looks like it's working properly before we do anything else. So here's us iterating over the downsample. And, you know, what you can see here, too, is it looks like we've got sort of an issue where technically the texture submission is not necessarily... Like, I don't actually know if this is... those values are not power 2 values, right? As we're going into the downsampler. And so I'm kind of wondering what exactly is supposed to happen with that texture submission. Hold on a second. Because didn't we just look and see that when we actually came through here, like the width and height of this was like 512 by 512, right? And so the problem, I think, yeah, like what, is this just a different one that finished up first? Because when we looked, we were only getting ones there that had width and height of like 512 by 512. So how are we now seeing something totally different than that? And I'm not sure. So in here, this is gonna not need to push to 512 by 512. So okay, I see basically what we're saying here. So yeah, we will have a problem with our downsampler, which is that our current downsampler isn't smart enough to handle the case where we don't have an actual power of 2, right? So we do need to do a little more work here in our downsample 2x. This thing needs to understand when it's going to oversample, right? Because otherwise it's going to fetch outside the image. You know what I'm saying? It needs to be aware of what happens at the at the second to last step, right? Furthermore, we would probably want to round up. So we've got some extra work to do here that's actually fairly complicated. So let's go ahead and do that as well. All right. So what I want to do here is when we're doing this iterate MIPs, and again, you can see why I wanted, hopefully this will underscore why I wanted to do this summation manually rather than writing a closed form version of it. Because as I modify this routine, I know that this one will automatically pick up the correct sum without me having to go redo the math. So looking at this, what I want to do here is I want to change this to round up. So what I want to do is I want to say, all right, it's going to be a divide by 2, but I'm going to add 1 first. That way I will always round up to the next value rather than truncating downwards always. Because I don't want to, like if you have the value 3 and you divide it by 2, I want to get down to 2. I don't want to get down to 1, right? So I want to keep extra space for things that weren't power of 2. The reason I want to do that is because I want to maintain the extra padding on the outside of things, because that's when we put in like borders around things for when they get shrunk down. I don't want the fact that they're smaller. I don't want the fact that we're downsampling to eliminate those borders unnecessarily. So I think I would rather do this than truncate. I don't actually know that that's true, because we haven't really quite looked at it, but I have a sense that that is what I would prefer. And then when we're actually doing our downsample here, what I want to do is make sure that I don't fetch outside of the source that's incoming. And so while we produce the destination, and we're looping through the destination, what I want to do here is make sure that, so basically this, I want to make sure doesn't oversample, and this I want to make sure doesn't oversample, right? Because you can kind of see that they might. So essentially what we've got is our X-based sampling. So this here, right? This wants to only happen in certain circumstances, right? We want to do something more like this. Right? So we want something that will prevent us sampling over the edge. And we could make a better loop than this that would be faster, that wouldn't have to do this if, but we're not going to do that at the moment. So I'll just kind of make a general note, though, that we could do a lot better than we are. All right, so looking at this, what we want to do is say, look, don't oversample. So just assume that there's zeros on the outside of this thing that you will then use if you cannot pick up a value, right? And I want the same thing to be true for the source, for the rows, but unfortunately that's a little bit harder, right? Because sampling rows actually requires that, like, this stuff, I don't have a way to set this pointer to something sensible, right? I could try to have just a giant set of zeros that I can point it to, and then this thing would work. But again, that's a little bit hairy. So we almost want to do something where we're going to have, again, a more optimized loop. I can cheese out, because if you look at how the extra rows are sampled, we can actually make it so that those are zeroed out as well by, again, using a strategic if as necessary. But again, not really sure to what extent I want that to happen. We can duplicate instead, which would be easier, because then it would just be you set this pointer equal to source pixel 0. I don't know if I necessarily love that. So I'm going to do the duplication because it's easier first. Because all I have to do is this. And I can do the same thing on X as well. It would just be this. Set it to what you just loaded, right? So given that, we can now do a downsample that should, in theory, properly operate on arbitrary rectangles, and it wouldn't need them to have been powers of 2 or anything else like that. So let's do that, and we'll just leave it at that. And then we can go back and watch this and see if it works properly, right? So here we are in Generate Sequential MIPs. Let's actually see what our downsample call is getting. It's going from 371 to 186. It's going from 217 to 109. That seems about right. Let me step out here. As this goes down, right, keeps going, keeps going, keeps going. Here's that bottom out case again. You can see it goes to 2-1 and then 1-1, and then it's done. That's all the MIPs produced. Hopefully it's correct. Then we complete that texture op and submit, right? Okay. So I think we're now at least roughly preparing the correct thing. If we go back now and look at our submission process, we have to make OpenGL happy about what we're doing. And so this part has to now be addressed as well. When we do GL text subimage 3D and we're passing down a MIP level here to submit, I don't actually know what it's complaining about. It could be any number of things. But, for example, one thing that it may very well be is the fact that when we created this, we may not have told it that we wanted space for mipmaps or things like that. So now, like I said, we've done sort of our part of the work, and now we're on to the OpenGL massaging, which is always a barrel of fun. So if we go look at where we were actually specifying these textures to begin with, that's going to be a GL text image 3D call or something like that in here somewhere. It looks like we fixed this bug, right? We don't have this anymore because we are calling GL text image 3D. So when we call GL text image 3D, if we look at the docs, if I go pull GL3 out here and I say GL text image 3D, and I look at what I'm actually calling, I want to go ahead and say, and I'm making this up 100%, because, of course, the docs would never tell you. I want to say that if we are to call GL text subimage, we may have had to have called GL text image first. So when we first announce this texture, we probably have to call all of the MIPs that we might ever call. Does that make sense? So we're probably going to have to do something that looks like this. And again, hopefully you can see just how nice this utility function is. Do you see why I wanted to write it this way? Because everyone can use it. So you never have to worry about complex computations in there being wrong between parts of the code. Because since everyone can just use it and know that it's calling the same code, you just get a really nice sort of buffer there where everyone's using the same values, thankfully, right? So yeah, I'm going to try this, which is to say I'm just going to announce for our texture array all of them here, where we just say, yeah, man, here's an announcement that we've got every level from 0 to 2 to the 9, so 0 to 9. Please know that that's the case, right? And I'm just going to hope that that has something to do with anything, right? Okay, so OpenGL is now happily accepting our textures. That's great. It looks like our downsampler maybe sucks, for example. Or who knows? I mean, we could have any number of bugs in here. But the good news is we're pretty close, right? We have submitted mipmaps to the system, and it is not rejecting them. We've got some garbage on the screen, so we've got some errors. That's fine. But what kind of makes me a little confused is I don't actually know why we would be using any of those mipmaps, because I didn't think we turned that on. Did we? So we're not sampling from the mipmaps yet. So to be completely honest, I'm a little confused as to what's going on there. It looks like maybe we've got a transfer error, or maybe we're not advancing our pointers correctly. Like maybe our downsamplers like writing garbage into the existing MIPs. I'm not sure what's going to be because we haven't told OpenGL to ever look at those MIP maps. We sent them down, but what you can see here is this texture min filter, texture mag filter. That setting it to linear is saying don't sample the MIP map, I think. Although that may not actually be true. It may be sampling the MIP map and just not trilinearly filtering it. No, I don't think so. I think when you specify texture min filter, you need to specify, yeah, it's not gonna pick a closest MIP. You'd have to do MIP nearest. Here, I'll show you what I mean. So if we look up the docs for GLText parameter I, what you can see is that there's a thing in here called min filter and mag filter. Those are the two settings that we have here. Min filter is what you use when you might be MIP mapping, actually, because that's when we're making the texture smaller than it actually would be. Mag filter, we don't care about. That's when you're blowing it up. You're never going to use the MIP in that case because you're actually stretching it, right? So that we don't actually care. But min filter, we do care about. And what we want to see here in min filter is we actually want to, got a section there on it, see what those settings actually are. So here's min filter, right? And here are our options. Nearest returns the weighted average vertex elements under the closest specified texture coordinates. This can include items wrapped and repeated from other parts of the texture, right? But since there's no MIP map in there, I don't think it will ever choose one. So you can see you would have to get GL nearest MIP map nearest at least, or GL linear MIP map nearest, in order to start using those MIP maps. So I'm pretty sure it will never actually use them in our case. That means I think we're overwriting our actual texture. What I'd like to do first, going to go into Handmade asset, going to take generate sequential MIPs, and I'm going to actually turn it off. So we're not calling the downsampler anymore. I just want to see what happens. Like, that's all I want to see. What happens if we don't downsample, right? Okay. So what that tells me is our downsampler is just producing stuff in the wrong place. And there's two reasons that could be happening. One is there's a bug in the downsampler. Two is that our MIP thing that we're using to iterate over to generate them is telling it the wrong starting pointer, which would then produce garbage because it's writing into the wrong place. So there could be bugs in either case, and we're going to try and find out what's going on there, right? Okay. So if we look at the downsample 2x source dest here, what you can see here is the destination's writing into dest and the source is writing into source. That's exactly what we would expect to have happen. When we look at where it's reading from, in theory, it should only ever be starting its right here. And if I go through and look, you can see dest pixel, the only place we're ever writing is right here. So I really think that that's an unlikely candidate. It looks like dest is getting past the wrong pointer potentially, or when we're submitting it, we're submitting via the wrong pointer or something like that, right? But it really looks like that dest is getting set incorrectly, and so that suggests to me that maybe down here we've got an issue with how these things are getting updated. It could also be potentially this computation in here where we're updating the pixel pointer, right? So I think that's what we want to start, what we want to look at in terms of who might be doing things wrong. All right. So when we come in here, when you see what we're doing in terms of data writing, I mean, it still looks pretty good, right? If you look at it, it's saying downsample source to dest. And that source is always going to be equal to the dest the next time around. I mean, in fact, you can even get dest out of the equation because it's just this. Right? And that's all we're doing. So yeah, I don't really know what's wrong with that. We're going to have to step through because I don't get it. If you look up here at where we actually advance the pointer. So when you first start, we just cast the pointer up. And say wherever you told us to start writing, that's where we're going to write. You know, no big deal there. when we need to actually advance the pointer, it's a pointer to a 4-byte value. We advance it by the width times the height. That's what you would expect to see. So I really don't know why that wouldn't get out of the way. Don't know. So I'm going to have to step in. I really couldn't tell you, but it looks like it's clearly doing it wrong. I mean, that's about all we can say. I'm going to go look at the code for that. Just going to set a breakpoint in there in Remedy and see if we can see something wrong. If not, it'll have to wait till next weekend, I guess. So coming through here, I'm going to delete this stuff and just focus on what we've actually got in our case here. So here's our starting data pointer. That's where we're saying the sequential MIPs we generated. If I pop back out to look at where that is, it's essentially saying that it wants to do it to this data pointer. That's where we did the load in the first place, I believe, right? So we do read data from file, handle, offset, size, destination. I assume that data, I guess I don't know that that data is set to the same place. I guess that's a good question. Is it? I mean, it should be, right? But let's verify, I suppose. Well, I guess I'm here now. Why not actually look? Let's just see. Work destination is that. Texture op data is that. So that seems good, right? That's what we would expect. If I jump down in here, well, that doesn't make a lot of sense. Oh, sorry. Yes, it does. So that's the correct value. That's what we would expect. Everything looks fine there. So the width and height in this case, 371 by 217. I want to go up here. I'm curious what the work size is. How big was it loaded? It was 322028. And so if I look at the actual width and height, I should see 322028 is the number that we actually get out when we multiply those two together and then multiply by 4. So it is, right? So we loaded the amount we thought we loaded. Now we're going to load up our MIP iterator with that value. Here we go. We're at level 0. We've got those two values in here. Here's our pixel pointer. It's pointing to this. What would I expect the next pixel pointer to be? So in this case, if I were to copy this value, I don't know why I can't click on that, but I guess I can. If I were to copy this value here, I don't think I can show this in hex, or maybe I can. Yes. Thank you, Remedy. So if I wanted to move to the next pointer in here, what I would expect to see is it would be this much further forward, right? So meaning I would expect after, I'm going to submit that image of that size, and then after that, I'm going to try to step forward by 322028 and get this value here, right? So that's what I would expect. So when we advance our MIP pointer, that is exactly what we get. And now when we call downsample, we would expect to see effectively us reading from here and writing to there, which I will again try to copy this value. There we go. All right. So we expect to see reading from here. We expect to see writing to, sorry. There we go. We would expect to see us read from this and write to that, right? I guess, so there's something weird, like, I guess Remedy doesn't let you click on some values, but it does let you click on others. I'm not sure. There's like some kind of weird, like, I can't click there, but I can click here. I don't know. It looks like you can't click on things you entered, but things that were expanded you can, right? So it looks like members of a thing, you can click out here on those, but if you typed it in, that's not clickable. right? Because all of these are ones I typed in and I can't click on the value. Yeah. So it looks like there's maybe something, it might just be a bug in Remedy where it doesn't, if you typed it in, it doesn't let you click on it. But if you didn't type it in, you can. Seems right. George is on the chat. He said he just fixed that 20 minutes ago. All right. Hey, man. Things you'll never hear from Microsoft about Visual Studio. I just fixed it is something you'll never hear them say about anything, really, because they don't ever fix anything. So thank you, George. We'll be looking forward to that update for sure. Anyway, so here's my downsample code. Let's just get in there. Let's try and figure out what we screw up, because we screwed something up, right? So let me take the source. Let's take the dest, and let's just look at what we're doing. So here we are doing our downsample. The source value for our pixels is exactly what we said it should be. The destination value for our pixels is also exactly what we said it should be. So as we write through here, I guess that suggests this isn't wrong. Exception thrown? Wait, how come we got an exception this time, but we didn't get one last time? What's going on there? That's weird. Can I get that? Can I provoke that exception? Please make exception. It does not want to. I'm not sure what that exception was. I'm not sure what that exception was. Why can I not make that exception happen again? Well, that's unfortunate. I would like to debug that, but I can't. Let's briefly look at a couple other things before we go any further. The get total size for MIPS. Maybe what I would like to do here is I would like to do a spot check. So what I'm going to do here is say, once we get to the end of this, I'm going to put in a check and say, assert that if I were to get, if I were to get the total size for this particular MIP chain, I want that to be equal to the mip.image, yes, the mip.image.data pointer that we currently have, which is the final pointer, right? Minus the original data pointer. And unfortunately, that's not quite going to be right just yet. And the reason is because this thing doesn't always happen. I'm going to make this always happen. And I think we're correct, right? And so all I'm doing here is just making sure that the size that I computed when I said how much room will this take up, when I actually go to generate the MIPS, I want to make sure they're the same. Because if they ain't, then we got a problem, right? That's pixels. And that just makes sure we've written to the same amount of space as we requested. It's a way of checking that math, right? So it looked like the MIP was working properly. I just want to make sure of that. And it is. All right. So we've got a weird bug happening here because we're asking for the right amount of size. And then we're using that. I don't know what we're doing wrong. That's kind of confusing. So in here where we're looking at the texture ops, I guess now I'm starting to wonder, like, is there something else more subtle that I don't understand about the way, like, that I've just forgotten because we haven't looked at this system in a while? Is there something more subtle that's going on here that's like, that I'm not appreciating? When we actually go in here and do the get total size for MIPS, like for this, for example, is there something weird happening here, right? Where the bitmap width and height is like different. I am kind of interested, why do we get this multiple times? Does anyone know what the idea is behind that? Because that seems kind of busted. We already have that information up here, so it kind of seems weird to get it again. I'm going to go ahead and get rid of that. That just doesn't really make any sense. So this work size here, that is still just the single mipmap size. What I might do there is say top level size and grab that. And that way down here I can just say top size. So that's the amount we load. That's just the size of the top level of the MIP, the biggest level of the pyramid, which you might call the base. And then, yeah, everything else follows from there. Now, unfortunately, I don't see us doing anything squinky here. It looks correct. So what else could go wrong there? So inside begin texture ops, you know, we don't use that width and height anywhere that I know of. You know, we're just using size requested pretty cleanly, so I feel like that should be okay. That seems fine, right? When we're pulling those texture ops off, so when we're pulling the texture ops off the queue, which is here, when we grab one of these things, again, I really don't see what the problem is. Maybe you guys already saw it, but I fail to see the special sauce here, right? You can see that the texture width and height are width and height are considered authoritative there. I'll be honest, I'm not sure why we use a 2D texture array for these folks here, but I guess we decided that was just an easier way to do it, and we don't care about some of the wasted space. I don't know. I can say that we could simplify that by not re-referencing the thing we already referenced up here. Not that it saves much space, but we might as well do it. And I don't see where we're going wrong there. When we're doing the submission, seems like that should just work. And I don't know why we would be getting overwriting of the image, especially since that first submission, I mean, you can see right here that it's using, it should be using the exact same data pointers. But the fact that if we turn off downsampling, that we don't overwrite it is just a real stumper. I don't know. So let's just go over this again. I'm gonna turn on optimize just to see if we got that crash. I want to provoke that crash if possible. Can we get that happening in optimize build by any chance? No. So in this case where we call the downsampler, we know that all we have to do is just turn off the downsampler and we don't get that. I'm assuming that's true even if I just went into the image processing and literally just turned off just the pixel write, I'm assuming. So meaning if I just get rid of that, so we're not writing the pixels, that we would still get the problem. So this still does everything except just the pixel write. Yep. So this, you know, we know that this thing here is writing into someplace it shouldn't write into. And I'm just at a loss because it looked like it was writing to exactly the right place. I'm just kind of at a loss as to how that's happening because it shouldn't be, right? And so that dest pixel problem is really the primary problem that we're seeing. And again, if we kind of look at here at what this MIP image pointer shows, I'm going to put in yet another assertion. I'm just going to add as many assertions as I can here to see if I can detect where that boundary error is happening. So let's say that I would just do U8 star, or well, here, assert. I've got a downsample from source to this, right? I want to assert that the source pixel pointer plus the source width times the source, times the source height times 4, right? That's the end of that bitmap. I want to assert that the end of that bitmap is where I start here. Right? So basically, if I added the full size of the source, that's where I'm starting to write next time. Just want to make sure that that's true. And we still get the error. Right? I mean, you see how weird that is, right? So we know we're still writing to where we would expect if we were completely done with it. I don't know. All right, so desperate times call for desperate measures here, so I'm gonna try something even more ridiculous. So inside downsample 2x, well, actually, I'm not even gonna call downsample 2x. So instead of calling downsample 2x, basically gonna put a if 0 around that. So instead what I'm going to do is I'm going to set a different color for each level of the mipmap so I can see what it looks like, right? So instead of calling downsample to X, I'm just going to call like fill image, which is just going to be some other call that we have. I'm going to say that I want to fill this image, whatever it is, with a particular color. That color is going to be based on the level. So we have a debug color table, do we not? Yes. And so what I want to do here is just call get debug color with the MIP level. And that will give me back a unique color, and I'll just pack that, right? What's our pack call? Yeah. So I'm going to say, give me a debug color. I want to fill the image with the MIPs going down. Since we know the debug color table has a particular order to it, right? We'll expect to see red at level 0, which we will not be filling. So we would never see that. The first level down will be green, the next level down will be blue, and so on, right? I'm going to call this fill image. This will be in our image library here, and it will just follow the same rules as downsample, so we can try to debug these, right? So it's going to take a dest and a color, right? Like that. And then what it's going to do is it's just going to loop over the entire thing, and it's going to fill it. So it's just going to say, all right, we have a particular dest pixel here in our dest pixels. We are going to make a count, and that's going to be the width times the height. And then we're just going to do like a while count minus minus star dest pixel plus plus equals color. So we're just going to fill that region with the color, and that's it, right? We don't know what that is here, apparently. So I'm not sure where the debug color table should live. I guess now that I think about it. But probably in shared. I would think we'd want that everywhere. So now if I run it, what do I see? Okay, so am I still calling the function? Because if so, that means it's literally just this call to downsample 2x that's broken. How is that possible? We are filling dest pixels just the same here. Okay. Yes. Don't ask me what I was thinking here. So for some reason, and I have no idea what the reason is, when we ported this routine, we looped over the source width and height, but we're writing pixels for that many. So actually, it's the dest width and height. We weren't writing over our mipmap. We were writing over like the next person's mipmap, right? But hey, that was pretty good. I mean, that was a good way to find that bug, I think. So I want to say I can turn on downsample now, and we should be fine. And we are. So, okay, so that seems all good. Right now, we should not be using the mipmaps. Like I said, they should not be turned on. So if I come over here and I zoom, yeah, I still see a fair bit of crispiness there, right? Which is what I would expect. And so all we really need to do now is see if our mipmaps work, is to just turn them on. And let's do that, and then we'll call it a day. Because, hey, we did all the implementation work. We might as well actually turn them on. Okay, so if we look at our GL text parameter I. Here they are. So when we're creating our MIP maps, I'm sorry, our textures here, you can see this is the frame buffer stuff. So we want the actual texture side of things. There it is. So here's our special textures. We're going to leave MIP mapping off on those. Here's our regular textures, and we want those to have the text parameter I set saying that we'll use MIP mapping. So that linear mipmap nearest. There's two different versions we can use here. Linear mipmap nearest is just going to say pick the right mipmap for the size the thing is on the screen, and then do a bilinear filter, right? There is also a linear mipmap linear, and that's what's generally called trilinear filtering. That's saying find the lowest and highest, the next down and the next up mipmap from where we are, because we're going to fall in between two mipmaps depending on where we are. Do bilinear filtering on both and then trilinear. I don't really want to do that. I'd like to try and make our renderer work without that, because again, it's just more texture samples that I don't think we need, because we're not really in a situation where I think trilinear would be required. So let's see whether we get any filtering here now. I don't actually know if we will. Let me hop out to an area that's got a lot of crispiness in it. Lovely. Much, much, much better. All right. When we get out here, I'm still seeing a little crispiness, but that may just be because we've got a lot of things that are kind of overlapping, and our Z fighting is hurting us a little bit. I'm not seeing texture crispiness, I don't think. So that's much nicer now that we've got our mipmaps going. And, you know, I don't know, we may have gotten some speed from that as well. It's hard to say, probably not, because almost all of our time is, I think, still spent. If we actually look here at the, oops, that's not the profiler, this is the profiler. If we actually look at the amount of time spent, you know, I think our lighting still dwarfs everything, and I don't know that we're really having a problem with anything else here. You can also see, look at how long render ground cover is taking, right? It's showing up now. It's not actually competing with lighting, but if lighting went away, it would be relevant. And that's just because there's just so much random computation pushing in there, right? And that's the thing I said, like, we can actually cache that stuff on the graphics card, and we could get rid of this entirely, right? We could make that go to 0. And so that's going to be something that we'll probably want to take a look at ourselves as a performance candidate as well. That's why I have it in there on the profile. Okay, so I think that's all for MIP mapping. I think we're now MIP mapping, like happy little MIP folks. We'll go to a brief Q&A, but I think that was really all there was. So not too much to it. A bunch of just plumbing, really. And then we had one little bug there that was just, you know, hard to see. It was a typo. But I think we're in good shape now, and those MIPs are going to help us out. They help keep that rendering nice and stable. It looks better already, actually. All right, so let's go to a brief Q&A, and then we'll call it a day. Is the mouse working, or is this Linux? The mouse is not working because it's Linux, of course. Let me go ahead and switch over to the other mouse, which does work, of course, because, you know, when you plug two mouses into a computer on Linux, one of them will work. Which one is always the question. Would you want to add shaders to the asset system? You might if you were going to have more of them. We don't have very many shaders, so it's hard to argue with making some kind of special pipeline for them. But if you were going to have hundreds of shaders, which, you know, a lot of games do have, depending on how they choose to go about that process, then, you know, you might. It really depends on your needs, right? Which textures are considered special textures, and why do they not want MIP mapping? So it's not necessarily that they don't want mip mapping. Special textures are these. So like stuff that's used for like cutscenes and stuff like that. So like these are all special textures. And the reason that they're special textures is because they don't fit in 512 by 512. They can't be like shoehorned into a small texture because they're big. I wouldn't necessarily say that we don't want mip mapping for them. I just didn't want to deal with that right now. So we may want to turn on mip mapping for them actually. I just didn't. So, you know, we have to think about it. What I would say is, based on the way they're used, we probably don't want all the mip maps for most of them. So it would probably be wasted effort if we generated the entire MIP pyramid for special textures. So it's hard to say what we really want to do there. But point being, the important thing is it's not that we don't want MIPs for them. It's that I only really care about MIPs for the other stuff right now, and we haven't really thought through whether we want MIPs for cutscenes or not, right? Off topic, can you explain the light blue selection bars in 4Coder? Oh, that was just the thing I tried adding that shows what the region is between the mark and the point. I ended up not really liking it, so I don't actually use it anymore in my main build. But it was just an experiment. Request to change the name of MIP iterator to MIPterator. Request denied. Through stream is difficult to notice. Can we please see through an image sent through chat difference before and after MIP maps? Yes, and well, we may be able to. I was trying to think if we could just add a switch easily that lets us turn MIP mapping on and off actually in place. So we actually could just do that. So like, I don't really remember how we did this, but so you see here how we've got like this call happening. We could just have a thing that when you do the change settings call, that happens. So like, where was that thing at? Here we go. So we could do something like this, where when we change the texture settings, we can put a thing in here that like switches between two things. So we can do linear mipmap nearest, or well, we could actually have it cycle between a bunch of things. If we want to. What we could do is say, where's those settings at? So this, right? Where we do the settings. Where's the settings stored? Game render settings. So in here where we've got like all this nonsense, we could have like we could do something like this. And then whenever you change the settings, we would go in and set this accordingly. So there'd be like, what is that, like a glue int or something? And then we'd have like some if nonsense. That would crack that value. And so this thing would be like texel filtering. And actually, I guess we could do this. Min filter. Mag filter. So what we could do here is we could actually set these things up where we say, okay, we've got a min filter and a mag filter that we're going to specify. Don't ask me why I put max in there. I think it's magnification. I don't actually know. And we'll set those based on what the settings suggest. So up here where we say settings, I can pull out, you know, settings. And you know what? These usually want to be set to 0 probably. So I probably want this to be like nearest texel filtering and no MIP maps, right? I want them to be opposite. So you like, by default, if you clear to 0, you just get the right settings. You know what I mean? So right here, we'll say nearest texel filtering and no MIP maps are the two things we're checking. And then we'll set these things up properly for all of those. All right, so if we have min filter, mag filter, see how we want to do this here. Oops. All right, so if we have nearest texture filtering on or off, basically what that's going to switch between is whether or not we're going to grab MIP maps here or not. So I guess I'll do this. All right. Maybe it's clearer to write it like this. All right, so what are all of our settings? So if we're in nearest texel filtering, then that means these should all be nearest. Right? And if we don't want MIP maps, then there's no MIP map selection either. If we're in this path, so we're like nearest texel filtering, then that's going to be, if there's no MIP maps, it's just nearest, which is, I'm sorry, it's just linear, like so. And if we are using MIP maps, then it's linear on both. Right? I think I missed a case there. No texel filtering, no MIP maps. That's there's no. So okay, sorry. This is linear, but no MIP maps. This is linear on both. I guess we don't have. In the case where we have linear and MIP maps, I didn't actually want this, so I guess we just don't have a case for that. It's just that, right? So since this is our default, I think I'll phrase it this way. Oh, and don't ask me why I was doing the mag filter the same, because you don't actually have to do that, right? The mag filter, you just know it only has one. It can't use MIP maps. So in this case, when we know that we have the default settings, then we don't have to do anything. So our default would be this. Right? So we would just say, look, nearest textile filtering, that means that the magnification turns off linear blending. Then we look, do we have MIP maps? If we don't, then it's also just nearest filtering. Otherwise, we're going to pick nearest on MIPMap, and off we go. Here, if we have no MIP maps, we set the minification to linear, so we turn off the MIP maps, but we leave on linear filtering. And we don't have to change the mag filter because it's linear always, right? So I think that's all we really need there. Okay, so then we just need some way of actually setting those things, which we don't really have at the moment. Excuse me. At least I don't think we do. So here's our renderer command settings. So we do have those going. All right, good. So what I want to do there is I want to just add that in where we're doing those render command settings stuff. I want to add those. I want to add settings so we can toggle these guys, right? So I just want to look for where we're doing that. Oops. And I just want to add these in. So I'm going to put that in there. And hopefully this will just let us, twiddle that and see the results. Okay, so hopefully now this is working. I don't actually know if it is or not. Let's see if we are still getting what we would expect to have as the correct results. So it looks like it's doing the MIP mapping properly right now. And it's also doing obviously smooth, it's blurring those out as it's sampling. So now let's see in here if we start playing with that. So if we turn on nearest textile filtering, we should get basically like pixel art. And you can see we sort of do, right? You can see, right? You see the difference between the smoothing that's happening there, right? The bilinear smoothing. So that is what we would expect to see. And then with no MIP maps on, we would expect to see, like, as we get out here, right? All of that should get crispier. See how it does? See how it gets much crispier? A lot of high frequency noise in there. So that filtering is just taking that down a notch. Is there an easy way to view the MIP map sent to the GPU? And if so, why didn't you use that feature for debugging purposes before? There is kind of. You can just use Nsight. It's not easy. I mean, it takes a little bit to set up, but you can use it. We've done it on stream before. The reason I didn't use that feature for debugging purposes here is because we knew they were messed up, right? We're like, okay, we know we're overwriting our main texture level, so why look at the GPU? It's just going to show me that. Right? I mean, the renderer was rendering it. So the question was, who was corrupting it? There was no graphics bug. The graphics stuff was working properly. It was me. I was creating the wrong MIP map. So switching, that's the reason I didn't switch to trying to debug GPU stuff. If I thought I was sending the GPU the correct stuff and we were still getting wrong results, then I would have gone and ran Nsight and said, let's see what it thinks it's getting, right? Because then that would be something I would be suspicious. Like, okay, what's going wrong here? But I knew right off the bat, just from that simple test at the beginning, I knew it wasn't the GPU. I knew it was us. And so I just really didn't need to look to see that. Some file formats like DDS have mipmaps already baked in. Is generating them better nowadays, or does it actually matter any longer? So I guess I would say that the premise of the question seems a little squirrely. The file format has it baked in, but somebody generated it, right? And so we would have just had to generate it when we saved out that file. So, you know, it doesn't really matter. The reason I'm generating them online here is because I don't want to waste the disk bandwidth during load time of loading the extra data. Just doesn't seem worth it. Because it's so fast to box filter down on a spare core. Why not? If, however, we found that that somehow was too expensive, then you might want to try loading it. I don't know. Anisotropic filtering next. I don't think we actually need anisotropic, so I would probably not turn it on. It's more expensive, and so I probably wouldn't turn that on, no. Looks like we're all set. All right. Abarishu, if we add some packing, would Mipmap interfere with that? Yes. One of the big things that you see that's a problem with texture packing, and it's also one of the big reasons we don't use an atlas and we use a texture array to begin with, is just as you start to work with packing, you have to do more. You have to be either you add a crap ton of padding, or you have to do specific work in your actual texture fetch. You can't use default texture fetch in order to prevent the mipmaps from blurring across boundaries of the things that are packed into the texels, right? And so there's a lot of subtlety there, and we're not going to go into it on Handmade Hero. If we pack things, we'll pack them with significant padding. But if you want to go down that road, you have a lot of stuff you got to sort of deal with, if that makes sense. If that makes sense. Fariandra, I don't watch you much, but I was wondering, are those settings you toggle, do you have a GUI so users can interact, or is that different? Yeah, so the if you're talking about this stuff up here, this is for developers only. So it's only in the developer build. When you turn developer build off for like a release mode, none of this stuff would show up, right? The reason for that is because this is pretty much all internal stuff that a user would not necessarily understand. And furthermore, most of it is stuff that they really shouldn't be playing with anyway. Like, we're going to set textual filtering to the correct settings, and that's it. It's not the kind of thing like... There are sometimes graphic settings that you want users to be able to set themselves, because enthusiasts will want to tweak their like performance or whatever on a PC card or something like that. Whether or not you're using MIP mapping isn't really one of those things anymore. Like, MIP mapping is either right or wrong in the situation, and the user doesn't need to fiddle with that. So, you know, this stuff probably wouldn't be settings that a user would ever actually wouldn't ever actually fuss with, right? So that's what I would say. All right, I think that's it for now. I'm going to go ahead and close up shop. All right. All right. Thank you, everyone, for joining me for the episode of Handmade here. It's been a pleasure coding with you, as always. If you would like to follow along the series at home, you can always pre-order the game on handmadehero.org. It comes with source code, so you can play around with it. And you can try your own render settings, see what you think. I'll be back here probably next weekend. I'll haven't updated the schedule yet, but I will. And we will be starting to tackle lighting, I think. Now that we've got MIPs in there, we're going to want to speed up our lighting, get that running fast, and light our sprites with it. And I think that will give us a pretty darn good looking engine. We probably want to change some of the way we're leaning on multi-sampling. I think we can optimize some stuff in the renderer that's just kind of wasteful right now too. So just tighten that up, get it to the point where we're pretty happy with looking how things go. And then, give ourselves a big pat on the back for making a complete game engine from scratch every last little bit. We probably should, before we give ourselves that pat on the back, replace sine and cosine. Those are the only two things we didn't write ourselves. We're still calling it the library version, I believe. So we'll maybe do that. And then we can give ourselves a nice big pat on the back. All right. That's it for this weekend. See you folks back here next week. Till then, have fun programming. And I'll see you on the internet. Take it easy, everybody.